Moscow, the main intelligence directorate, GRU. November 1955. The room smelled of stale tobacco and wet wool. Outside, the first heavy snow of the Russian winter was burying the Kremlin walls, muting the sounds of the city. But inside the cramped, windowless analysis room of the GRU's technical directorate, the silence was heavy for a different reason. It was the silence of men who were looking at something they could not explain. On the table, illuminated by the harsh glare of a single overhead bulb, lay a series of grainy, high-contrast photostats. These were not battlefield reconnaissance photos. They were leaked industrial concept sketches, sourced from deep within the American defense industry complex in Detroit. Colonel Victor Belov, a veteran of the Great Patriotic War and an expert in armored warfare, stared at the image. He had spent the last decade studying the evolution of the American M48 Patton tanks and the British Centurion tanks. He knew every bolt, every weld line, and every vulnerability of NATO armor. He knew how a tank was supposed to look. A tank was a box of steel on tracks, with a turret on top and an engine in the back. It was a machine of geometry and predictable physics. But the thing on the table was not a tank. It looked like a biological anomaly. It looked like a deep-sea organism that had been dredged up from the pressure of the Marianas Trench and placed on treads. It was a massive, bulbous pod, a perfect, seamless teardrop shape balanced precariously on a lightweight chassis that seemed far too fragile to support it. "This is a joke," Belov muttered, tapping the paper with a callous finger. "Disinformation. The Americans are laughing at us. They want us to waste rubles, analyzing a drawing from a science fiction magazine." The intelligence officer who had brought the file, a young major named Kogan, did not smile. He reached into the folder and pulled out a second sheet. This one contained preliminary specifications intercepted from a communiqué regarding the Astron project proposals. "It is not a joke, Comrade Colonel," Kogan said softly. "The Americans are serious. They call it the TV-8. Look at the armor slope. Look at the internal volume calculations." Belov leaned in. The schematics made no sense. In every tank in history, the crew was separated from the engine. The driver sat in the hull, the gunner and commander sat in the turret. The engine roared in the rear, separated by a firewall to prevent the crew from burning to death when a shell hit. This layout was the gospel of tank design. The TV-8 violated every verse of that gospel. According to the schematic, the hull was empty. It was just a hollow shell of aluminum and light steel. There was no engine in the back. There was no driver in the front. "Where is the crew?" Belov asked. "Here," Kogan pointed to the massive, bulbous head. "And the gun?" "Here, in the head." "And the engine?" Kogan hesitated. "Also in the head, Comrade Colonel. Everything is in the turret. The crew, the gun, the ammunition, and the power plant. All of it sitting inside one armored egg." Belov felt a cold prickle of unease on the back of his neck. To put the engine inside the fighting compartment with the men was suicide. The heat alone would cook them. The noise would deafen them. Unless the Americans had found a way to create an engine that generated no heat and no noise, or unless they had found a power source so dense, so compact, and so powerful that it eliminated the need for a traditional transmission and drive shaft. He looked closer at the concept art. There were no exhaust pipes. There were no intake grills for a diesel radiator. A 30-ton machine of war does not move without breathing air and spitting smoke. "What powers it?" Belov demanded. "That is what we do not know," Kogan admitted. "The intercept mentions a vapor cycle power plant. But look at the range estimates, Colonel. They are not listing range in kilometers. They are listing it in duration." Belov's eyes narrowed. A tank that didn't measure fuel in liters, but in time. The implications were terrifying. The Soviet Union was currently pouring resources into the T-54 tanks and the heavy IS-3 tanks. These were formidable machines. But they were tethered to supply lines. They needed fuel trucks. They needed rail depots. If the Americans were building a tank that did not need to stop for fuel, a tank that could drive from Frankfurt to Moscow without a single logistical pause, the entire Soviet defensive strategy in Eastern Europe was obsolete. But the confusion deepened. Kogan flipped to the third image. It showed the vehicle in a testing environment, but it wasn't on the proving grounds of Aberdeen. It wasn't in the mud or the sand. The tank was in the water. "It swims?" Belov asked, incredulous. "It doesn't just ford rivers, Colonel. It floats. The The report says the displacement of the turret is so great that the vehicle is inherently buoyant. It functions as a boat. The tracks act as paddle wheels. Belov sat back, lighting a cigarette to steady his hands. The smoke curled up toward the light. He tried to visualize this machine on the battlefield. A swarm of giant, faceless metal eggs emerging from the dark waters of the Rhine, silent, exhaustless, climbing the banks and advancing relentlessly. It was a nightmare image. It was the kind of technological leap that kept men like Belov awake at night, the fear that the capitalist West, with its infinite money and reckless ingenuity, had stumbled upon a law of physics that the Soviet scientists had missed. The armor profile, Belov noted, forcing himself to be analytical. It is curved in 2 dimensions, a complex compound curve. Ricochets, Kogan nodded. A conventional armor, piercing shell would slide right off. It has no flat surfaces. It is a ballistic ghost. This was the crisis. It wasn't just a new tank. It was a new kind of warfare. If the Americans were willing to put the entire mechanical guts of a tank into the turret, they must have solved the weight problem. And if they had solved the weight problem while carrying heavy armor, they were using materials the USSR did not possess. We need to know what is inside that shell, Belov said, his voice dropping to a gravelly whisper. If they have an engine that fits in there, alongside the crew, and powers a 30-ton vehicle through water, we are 5 years behind. Maybe 10. He looked at the date on the file. 1955. The Americans were already testing this? Send a priority cable to the Residentura in Washington, Belov ordered. I want to know who is building this engine. Is it General Motors? Ford? It is Chrysler, Colonel. Chrysler, Belov repeated the name. The car makers, the ones who made luxury sedans for the bourgeoisie. Since when do car makers build nightmares? If you are fascinated by the hidden history of military technology and the secret arms races that defined our world, make sure to subscribe to Cold War Impact. We uncover the stories that the history books often leave out. Belov stared at the alien shape on the paper one last time. He didn't know it yet, but the lack of exhaust pipes was the key. The vapor cycle was a cover term. The silence of the engine wasn't because of efficient mufflers. The Americans weren't just building a tank, they were trying to bottle the sun. The order went out that night. Every asset in the American industrial belt was activated. The Soviet military machine had to understand the impossible anatomy of the Chrysler TV-8. They had to understand how a tank could look like a spaceship, float like a boat, and potentially run forever. The investigation had begun, but the answers they would find would be far stranger and far more dangerous than simple steel and diesel. Leningrad, the Kirov Plant Design Bureau, January 1956. The mystery of the American Astron project had moved from the intelligence offices of the GRU to the drafting tables of the Soviet Union's premier tank designers. Colonel Belov stood in a cavernous workshop where the air tasted of iron filings and ozone. In the center of the room, engineers had constructed a crude wireframe mock-up of the TV-8 based on the stolen dimensions. It was even more unsettling in 3 dimensions. Dr. Nikolai Volkov, a lead engineer who had worked on the legendary IS-3 heavy tank, walked around the wireframe, shaking his head. He held a slide rule like a weapon. It is an anatomical absurdity, Volkov declared, gesturing to the massive upper section. Look at the weight distribution. The turret is nearly 15 tons. The hull is nothing. It is a sled, a dumb platform. Belov walked to the wireframe. This was the second layer of the mystery. In every tank previously known to man, the hull was the spine of the beast. It held the engine, the transmission, the suspension, and the driver. The turret was just a weapon mount. The Americans have inverted the organism, Volkov explained, pointing to the empty space in the mock-up's hull. According to the schematics, the hull contains electric motors and tracks. That is it. No drive shaft, no transmission tunnel, no crew. The driver? Belov asked. Up here, Volkov pointed to the ceiling, to the bloated turret. He sits next to the gunner. Belov tried to imagine it. A driver sitting in a rotating turret, trying to steer a chassis that was stationary beneath him. If the turret turned 90 degrees to the right and the driver pressed forward, the tank would move sideways relative to his vision. It was a recipe for total sensory collapse. How does he steer? Belov asked. If the turret spins, he loses his orientation. That is where the Americans are either geniuses or madmen, Volkov said, picking up a technical translation. They claim the driver's station is gyroscopically independent, or they are using video feeds. This was the detail that had caused the most arguments among the analysis team. The designation TV-8 was not just a code name, it referred to the tactical vision system. The intercept reports claimed the tank had no direct vision blocks for the gunner or the commander, no periscopes, no thick glass slits. Instead, the crew was sealed inside a steel vault, completely blind to the outside world. They would see the battlefield through closed-circuit television cameras mounted on the exterior. Cameras? Belov scoffed. On a tank? One piece of shrapnel, one bullet, and the crew is blind. A television tube is fragile. Why would they replace 3 inches of bulletproof glass with a vacuum tube? Volkov paused. He looked at the mock-up, his expression darkening. Because of what they are trying to keep out, Colonel. Glass lets in radiation. Glass lets in the flash of a nuclear detonation. If you use cameras, you can seal the crew in a lead-lined box. You can protect them from the prompt gamma burst of an atomic bomb. The room went silent. The pieces were starting to click together, forming a picture that was far more sinister than a simple battle tank. The shape, the weird, pod-like teardrop, was not for style. It was aerodynamic, but not for wind. It was aerodynamic for a blast wave. If a nuclear bomb went off nearby, a square tank like the Soviet T-54 might be flipped over by the shockwave. But this round, egg-shaped thing, the shockwave would flow around it. The radiation would be blocked by the lack of vision ports. They are building a doomsday tank, Belov whispered. They expect to fight on a battlefield that is already radioactive. But there was a mechanical problem that still didn't make sense. Volkov led Belov to the rear of the wireframe turret. The power, Volkov said. This is where the deception lies. The Chrysler proposal lists a V8 engine coupled to an electric generator. It says the engine turns the generator sends power down a cable to the electric motors in the tracks. A hybrid, Belov noted. Ferdinand Porsche tried that in the war. It was heavy and unreliable. Exactly, Volkov snapped. It is inefficient. You lose power at every conversion step. Heat to mechanical, mechanical to electric, electric to movement. Why do it? Why put a massive V8 engine inside the turret? It makes the turret huge. It makes the silhouette a giant target. And it adds heat to the crew compartment. Volkov slammed his hand on the table. Unless the V8 is a placeholder. Belov looked at him sharply. A placeholder for what? You only use an electric drive transmission if you have a power source that cannot be directly connected to wheels, Volkov reasoned. Steam turbines, gas turbines, or... He trailed off. He reached for a different file, one marked with the highest classification. It contained heat signature analysis from the spy planes that had flown near the Detroit proving grounds. We found a discrepancy in the thermal output, Volkov said quietly. A normal V8 engine exhausts hot gas in pulses, puff, puff, puff. The thermal signature we see on the theoretical models, it is continuous. It is a steady, high-pressure heat stream. Like a jet engine? Or a boiler, Volkov corrected. The Americans are calling it a vapor cycle engine in their Phase 2 documentation. Do you know what uses a vapor cycle, Colonel? Belov shook his head. A steam engine, Volkov said. You heat a fluid, it turns to steam, it spins a turbine, it cools down and it repeats. It is a closed loop. But to run a steam engine big enough to move a 25-ton tank at 40 miles per hour, you need a fire. A big fire. There is no room for a coal furnace in there, Belov said dryly. No, Volkov agreed. But there is room for a heat exchanger, and if the heat is coming from something that doesn't need air, something that generates heat just by existing. Belov felt the blood drain from his face, the vapor cycle, the sealed crew compartment, the camera eyes to prevent radiation leaks, the shape designed to survive a shockwave, and now an electric transmission designed to separate the power source from the wheels. The puzzle was resolving into a terrifying image. The Americans weren't just building a tank that could survive a nuclear war. They were building a tank that was a nuclear weapon. You think they are putting a reactor in there, Belov said. It wasn't a question. I think, Volkov replied, staring at the empty space in the rear of the wireframe turret, that the Chrysler Corporation has figured out how to shrink a power plant the size of a building into a box the size of a refrigerator. And if they have done that, Colonel, then God help us all. Belov looked at the mock-up. Suddenly it didn't look like a clumsy egg. It looked like a mobile Chernobyl. "We need proof," Belov said, grabbing his coat. "We need to know what fuel they are using. If it is uranium, we need to know the enrichment levels. If they put a reactor on the front lines and one of our anti-tank shells hits it, a dirty bomb." Volkov finished the thought. "Every time we destroy one of their tanks, we contaminate our own land." The stakes had just escalated from a tactical disadvantage to a continental environmental disaster. Belov needed to find the specific design of the reactor. He needed to know if the Americans were truly mad enough to put a splitting atom next to a soldier's head. The answer lay in a specific document referenced in the footnotes of The Intercept, the hydrocarbon versus nuclear fission cost analysis. Belov walked out into the snow. The cold air hit him, but he was sweating. The Chrysler TV-8 was not just a tank, it was a chariot of the apocalypse, and he had to find out if the engine was already running. Leningrad, the Krylov State Research Center, May 1956. The mystery of the American Astron had moved from theoretical blueprints to physical simulation. Colonel Belov stood on a metal gantry overlooking a massive hydrodynamic test basin, a 1,000-foot-long canal of dark, still water used to test the hulls of Soviet destroyers and submarines. Today, however, there was no sleek naval vessel in the water. Bobbing in the center of the tank was a quarter-scale model of the Chrysler TV-8 turret. It looked ridiculous. Without its tracks, the tank was just a giant, armored bean. But as the technicians turned on the wave generators, simulating the chop of a river crossing, the object did not sink. It rode the waves. "Archimedes was right," Dr. Volkov shouted over the roar of the water pumps. "It displaces enough volume. The turret is not just a gun platform, Colonel. It is a boat hull." This was the first breakthrough in understanding the tactical doctrine of this machine. For decades, tanks had struggled with water. They needed bridges, or they needed clumsy snorkels, long tubes sticking out of the water to feed air to their diesel engines. If the snorkel leaked, the engine died. If the water was too deep, the pressure crushed the hull. But the TV-8 was different. "Look at the propulsion." Volkov pointed to the rear of the model. A jet of water was shooting out from the back of the turret. The tank was propelling itself. "Water jets?" Belov asked. "Driven by the main turbine." Volkov nodded, his eyes wide with a mix of respect and fear. "And because the engine is nuclear, it needs no air." Belov gripped the railing. The realization hit him like a physical blow. A diesel engine needs oxygen to burn fuel. A nuclear reactor does not. A reactor is a heat rock. It works just as well in a vacuum or at the bottom of the ocean. "They have built a submarine tank," Belov said, his voice barely audible. "They can cross the Rhine, the Elbe, or the Danube without surfacing. They can drive along the riverbeds, or float across the surface, with infinite range." It was a strategic checkmate. The Soviet defensive lines were built around rivers as natural barriers. If the American tank force could simply float over them or drive under them without logistical support, the Red Army's geography was useless. But as the test continued, Volkov led Belov away from the pool to a side office where he had laid out the internal schematics of the reactor shielding. This was where the thrill of the engineering marvel turned into a horror story. "We have solved the weight mystery," Volkov said, unrolling a diagram of the crew compartment. "We couldn't understand how they fit a reactor and heavy lead shielding into a 30-ton vehicle. Lead is too heavy. Concrete is too bulky. So how did they do it?" "They didn't," Volkov said grimly. "They aren't using lead." He tapped the diagram. "They are using the fuel itself, and the structure of the tank." The schematic showed a terrifying labyrinth of pipes. The reactor was not a solid block buried deep in the vehicle. It was a sprawling system. To save weight, the designers at Chrysler had integrated the shielding into the armor. The steel that stopped bullets was also the steel that stopped the gamma rays. "And look here," Volkov pointed to a bulkhead separating the crew from the reactor core. "It is 15 inches thick, but it is not solid steel. It is a waste heat firewall." Meaning the crew is sitting inside the cooling loop," Volkov said. "The heat from the reactor is piped around the crew capsule to keep them warm in winter, and to dissipate heat through the outer skin." Belov felt a wave of nausea. "They are using the crew compartment as a radiator?" "It is efficient," Volkov admitted. "But consider the battle damage. If an armor-piercing shell penetrates the turret, it doesn't just kill the crew, it severs the cooling lines. The superheated radioactive steam vents directly into the faces of the gunner and commander. It was a suicide pact. In a conventional tank, a hit might cause a fire, but the crew could bail out. In the TV-8, a penetration meant an immediate atmospheric breach of the reactor coolant. The crew would be boiled and irradiated simultaneously. But there was one final twist in the documents that Belov had missed until now. It was hidden in a subsection titled Emergency Static Defense Protocol. Belov read the translation, his brow furrowing. Separation of chassis? Volkov nodded, pulling out a sketch that looked like something from a nightmare. This is the true genius and the true madness of the design. The Americans know that the tracks are the weak point. A mine can blow off a track. A rocket can destroy a wheel. So the TV-8 is designed to die, Volkov said. If the chassis is destroyed, the crew can detonate explosive bolts. The entire bottom half of the tank, the tracks, the wheels, the electric motors drops away. Belov stared at the image. The turret, the massive egg containing the reactor and the gun, would fall to the ground. It becomes a pillbox, Belov realized. A nuclear-powered automated fortress. Exactly. Even if you immobilize it, you cannot kill it. It sits there, powered by its atom heart, rotating its turret, firing its gun, forever. It doesn't need fuel trucks. It doesn't need a driver. It just sits and kills until the reactor runs dry. Which takes how long? Months, Volkov replied. Maybe years. The room seemed to get colder. The concept was monstrous. The Americans were envisioning a war where the tanks didn't need to come home. They were planting seeds of permanent steel sentinels across Europe. We have to stop this, Belov said, pacing the small room. If they build 1,000 of these, there is no winning a ground war. We need to find the flaw. Every machine has a flaw. Where is it? Volkov hesitated. He reached for the final folder, the one labeled Atmospheric Venting Analysis. I think I found it, Colonel, but you are not going to believe it. It is not a flaw in the armor. It is not a flaw in the reactor. What is it? It is a flaw in the sky, Volkov said enigmatically. The reactor relies on an open-cycle vapor system for peak power. Do you know what happens when you open a nuclear steam cycle to the air? Belov shook his head. It breathes, Volkov said. It breathes out. Volkov laid the final chart on the table. It showed the radiation plume of the TV-8 during high-speed maneuvers. It wasn't zero. To move this tank at 40 miles per hour, Volkov explained, they have to vent the excess pressure. They are not capturing 100% of the exhaust. They are venting slightly radioactive air out of the back. Belov stared at the chart. It leaves a trail? A trail of death, Volkov corrected. If a platoon of these drives through a German town, the tank survives. The crew survives. But the villagers walking on the street behind it. Radiation poisoning, Belov finished. They are building a machine, Volkov concluded, that kills the land it is trying to defend. This was the leverage Belov needed. But he still didn't understand why the project had suddenly gone silent in the American intercepts. If the Americans were crazy enough to build the bomb, surely they were crazy enough to build this tank. Unless something else had scared them. Unless they had found something even the Soviets hadn't seen yet. Get the file on the tactical vision again, Belov ordered. The cameras. We missed something about the eyes. Moscow, the Kremlin archive. August, 1956. The seasons had changed, but the cold dread inside Colonel Belov had not. The investigation into the Chrysler TV-8, the floating, nuclear-powered, windowless anomaly, had reached its climax. For months, the Soviet military intelligence apparatus had treated this machine as an apex predator, a technological leap that threatened to make the Red Army obsolete. But inside the final analysis dossier, the truth was waiting. And it wasn't a story of American supremacy, it was a story of American hubris. The breakthrough came from the electronics division. Belov had ordered a stress test on the tactical vision concept. If the Americans were replacing periscopes with cameras to protect the crew from the flash of a nuclear bomb, the cameras themselves had to be miraculous. They weren't. Major Kogan walked into the room carrying a heavy piece of equipment, a standard 1956-era Vidicon television camera tube, similar to what Chrysler was proposing for the TV-8. We ran the simulation, Colonel, Kogan said, setting the tube on the table. He looked tired. We exposed this sensor to a light intensity equivalent to a 20-kiloton detonation at a distance of 3 miles. And, Belov asked. It didn't just go white, Kogan said. It burned. The phosphor on the screen retained the image of the flash. It is called burn-in. Even after the light fades, the camera is blind. It sees only the ghost of the explosion. Belov stared at the tube. The implications were horrific. The TV-8 was designed to fight on a nuclear battlefield. The crew was sealed inside a steel egg with no windows, relying entirely on these cameras to drive and aim. But the moment the first tactical nuke went off, the very event they were built to survive the electromagnetic pulse, EMP, and the intense light would fry the camera circuits and burn out the lenses. They would be blind, Belov realized, instantly. Worse, Kogan added. Because the crew compartment is sealed to keep out radiation, they cannot open the hatch. If they open the hatch, the fallout kills them. If they stay closed, they are sitting in the dark, next to a nuclear reactor, unable to move, unable to shoot. The ultimate weapon was actually a steel coffin. The advanced technology that was supposed to save them was the exact thing that would kill them. But the dossier contained a second revelation, one that transformed the TV-8 from a military threat into a logistical nightmare. It concerned the maintenance of the vapor cycle engine. In a T-54 or a Patton tank, if the engine broke down, a mechanic climbed onto the back deck, opened a hatch, and fixed it with a wrench. It was dirty work, but safe. "How do you fix a broken track link on the TV-8? Belov asked, reading the translation of the maintenance protocols. The answer was absurd. Because the reactor was integrated into the armor and the coolant lines ran through the chassis, the entire vehicle was effectively a low-level radiation source. You couldn't just send a mechanic out to fix a thrown track. The mechanic would need a lead suit. They cannot be repaired in the field, Kogan explained. If a TV-8 breaks down, you cannot tow it. It is too heavy. You cannot fix it. It is too radioactive. You have to abandon it. Abandon $1 million nuclear reactor? Yes. And then you have to guard it, Kogan continued. Because if you leave it there, you are leaving weapons. Grade nuclear material in the middle of a field. The enemy could steal it. Or, if the containment fails, it poisons the local water table. Belov sat back in his chair. The picture was complete. The Soviet engineers had been baffled because they were looking for a military logic that didn't exist. They assumed the Americans had solved the problems of weight, shielding, and safety. In reality, Chrysler hadn't solved anything. They had simply ignored the consequences. The shock of the TV-8 wasn't its power, it was its fragility. It was a tank that could destroy a city just by parking in it. If a single enemy shell penetrated the turret, not even destroying the tank, just cracking the coolant lines, the superheated, radioactive steam would vent into the atmosphere. "It is a dirty bomb on treads," Belov whispered. "If we fought these tanks in West Germany, we wouldn't need to shoot them. We would just wait for them to break down. Then the Americans would poison their own allies trying to recover them." The final nail in the coffin came from an intercept regarding the US Army's own evaluation, the Astron report. The Americans had come to the same conclusion. The report was brutal. It stated that while the concept of a nuclear tank offered infinite range, the tactical utility was zero. The vehicle was top-heavy. The floating capability was dangerous. In rough water, the high center of gravity made the tank prone to capsizing. If a nuclear tank capsized and sank in a river, recovering it would be an environmental catastrophe. Furthermore, the cost. For the price of one nuclear-powered Chrysler TV-8, the US Army could build 10 conventional M48 tanks. 10 conventional tanks could outflank, surround, and destroy one blind radioactive egg. Belov closed the file. The fear that had gripped the GRU for a year evaporated, replaced by a strange sense of pity. "They tried to force the future," Belov said. "They thought that just because they split the atom, they could make it do anything. They wanted to put a star inside a car." "So, the project is dead?" Kogan asked. "It never lived," Belov replied. "It was a phantom, a fever dream of the atomic age. The Chrysler TV-8 never went into mass production. The massive, alien-looking mock-up was dismantled. The plans were shelved. The concept of the nuclear-powered battle tank died not on the battlefield, but in the physics lab, killed by the simple reality that war is dirty, chaotic, and violent, the worst possible place for a delicate nuclear reactor. The Soviets went back to building their T-55 seconds and T-62 seconds, simple, rugged, diesel-belching machines that worked. They had learned a valuable lesson. Complexity is not always superiority. Sometimes, the most dangerous weapon is the one that actually works. The mystery of the floating nuclear tank was solved, It wasn't a super weapon. It was a monument to the dangerous optimism of the 1950s, a time when engineers believed they could build anything without stopping to ask if they should. And somewhere in a Detroit warehouse, the blueprints for the strangest tank ever designed gathered dust, a silent testament to the time the world almost saw nuclear reactors charging across the battlefields of